Good morning, everybody, and welcome again to the MINEX Moscow Masterclass series. "2001 has again been a challenging year. We emerged from 2020 isolation and work from home arrangements, but there's still a cloud hanging over the world community, and the COVID virus continues to dominate our actions and discussions. We've been very fortunate that the communications of the last 10 years, advancements in communications over the last 10 years are available. Without them, the situation would be very different, and the world would be facing a much deeper catastrophe than it already is. The topics to be discussed at today's masterclass are a good example. We have assembled 3 specialists from the AMC advisory group in Australia to share their experiences and knowledge. They cannot move in and out of the country easily. However, technology has enabled them to be in the room to share in this masterclass with us. In mining, improved technology allows collection of enormous amounts of data, and we now have tools to improve analysis. But still, many of the approaches and techniques to turn analysis into practical applications remain the same as those we've used in the past. With the new data and methods enabling more detailed analysis and refined conclusions, data is still the bedrock of our work, and finding and developing resources and ensuring we have good data is vital to the success of all new systems and technologies. Before we get started on the masterclass topics, I'd like to once again provide some brief context about the mining industry. Commodity prices have been rising steadily since their bottom in 2015. After 4 years of very modest gains, we saw prices accelerate in 2020, and it looks as if rises will continue again in this year. Exploration budgets, however, saw a low point in 2015, and after some brief signs of increases in 17 and 18, we saw budgets stall and again start to fall in 2019 and 20. I believe that the sudden increase in prices during 2020 will prompt more money to flow into the resources industry and an increase in exploration. We've already seen significant increases in mergers and acquisitions activity. This is great news, but will it make a difference? The global performance in finding new resources has been poor in the past 10 years or so. I've mentioned this before over the last few years as a cause for concern. I believe that a contributing factor to this situation is the trend towards spending more exploration funds in jurisdictions that are considered less risky. While this results in a lower risk profile for exploring companies, that profile is based on lower overall discoveries. I believe this can't continue, and the pressure of increased commodity prices will inevitably lead to more exploration in areas where there is a higher chance that significant deposits are still to be found. This includes Russia and neighbouring Central Asian countries. Looking at the supply and demand mismatch, we turn to the current copper market as an example. Over the past year, we've seen mine production stagnate, while demand has increased, and this results in a market that's in significant deficit for the last 5 years. The end result is that the inventories at the start of 2021 are the lowest seen in the last 7 years, down by 1/3 in the last 3 years. And the realisation of this situation has fuelled the recent copper price rises. As professionals in the industry, we appreciate how long it takes to develop a mine from exploration target to production. For base metals operations, this is often 10 to 15 years or more. And when we consider the combination of low exploration expenditure and success, I believe copper stockpile situation can only get worse, or better if you're a producer looking for higher prices. Reversing this trend will require a significant increase in the spending on exploration, studies and development. Other commodities are in a similar situation. So what's happening in Russia? This graph shows Russia's share of exploration expenditure in US dollar terms has risen to about 5% of the global total. Considering the devaluation of the ruble, this increase translates to significantly more activity on the ground. Brownfields expansion projects tend to develop quickly, and exploration on feasibility studies over the past 3 years should start to show some results over the short term. Most money is still, however, going into gold and diamonds, so the Russian contribution to solving the problem in the base metals sector is significant, but still not sufficient to turn the tide. Russia remains a key global producer of many metals. This is particularly the case for the key battery manufacturing metals of nickel, cobalt and PGMs. So increases in world prices should also see further improvement in the resources industry in Russia and significant contribution to the future of battery manufacture. Production costs remain under control due mainly to the weakening of the Russian currency. The industry has benefited significantly through the devaluation, which has enabled higher returns to producers and allowed further exploration, development and production to take place. It is likely, however, that as exploration, mining and processing activities increase, then shortages will start to arise and costs for production and services will begin to rise. It's against this backdrop that we present this year's AMC Masterclass. The industry is likely to need additional metals in a hurry as the production to supply gap drives prices higher. Producing more from the deposits we have and those that will soon come online will be critical. For that reason, we've asked the AMC Advisory Group to discuss 3 streams of work which bridge the gap between technical solutions and the commercial realities that drive our business. I believe that technical and commercial considerations need to be assessed together to realise value on offer in a project. This holistic approach allows the wider objectives of a company to be included in the mine planning approach. We also use the same approach to include environmental, social and corporate factors during feasibility stage of project development, as retrofitting changes at a later stage can be very costly once the project basis of design is set and construction begins. But on to the presentations. We've got Ian Lipton, head of our geometallurgy group. He's returned to the Masterclass series to report on experiences from conducting recent predictive geometallurgy studies and application of 3D models. Ian is a geologist by training with more than 35 years' experience. His focus on predictive geometallurgy has led to significant improvements in the approach and particularly the application of metallurgical findings to resource models, making them available to strategic mine planners. We've got Jason Tolley, leader of our strategic optimisation group. He will discuss the strategic planning and the role of the hill of value concept. Jason's got 15 years' experience in all aspects of mine planning and now has a focus on strategic planning and the increasingly relevant role played by hill of value principles when increasing data and analytical tools provide improved inputs. But we start with David Vink, leader of our Operational Excellence Group, who will discuss our approach to using performance diagnostics to unlock the value of deposits by improving productivity in the mine and plant. David has a wide range of business improvement experience, gained over 30 years in the industry. Welcome, David. The presentations from Australia are recorded, but we will have the ability to ask questions at the end.
Thank you for joining me here today to listen to AMC's Operational Excellence presentation, Unlocking Value with Performance Diagnostics. My name is David Vink, and I'm AMC's Advisory Lead for Operational Excellence. Our team provides services globally and in every jurisdiction. I have 30 years of industry experience, including as a mining executive, Chief Operating Officer, and Group General Manager. During this time, I've worked in the energy, precious and base metal sectors and in underground and open cut operations. 10 Times Performance Diagnostics is an AMC brand. The performance diagnostics work that Operational Excellence does is assured to uncover hidden value in every operation. So much so that we're confident it will be at least 10 times the value of our fee, and in many cases, significantly greater than that. In this presentation, we will introduce performance diagnostics and its objectives. We'll break down performance diagnostics into 3 key components and look at a sample of the outcomes from a recent study. We'll finish with a slide explaining some of the reasons our clients are engaging with us to meet their performance diagnostics needs. Mining operations go through substantial change from the point of feasibility to construction and then into operations. Some of the challenges faced by operations include work practices, systems, equipment productivity, and rapidly changing technology. AMC's performance diagnostics, validated against the world's largest database, provides an objective way of understanding a mine's current performance and its future potential. Opportunities to create value are clearly identified by AMC during the assessment phase and prioritised according to our clients' needs. Over the past 20 years, AMC has compiled the world's largest and most comprehensive site-level validated mining data set. This contains all the available physical and cost performance information from over 250 open pit and underground mines. Because the data has been collected globally and on every continent, AMC is able to provide locally relevant comparisons to any mine. It's a fast process, and generally within 6 weeks from the site visit, AMC is providing findings and agreeing the next steps with our client. We begin a performance diagnostic by establishing the base year, which is usually the last complete financial year. This then becomes the time period during which our assessment of performance, practice and systems is completed and compared to peers. Our method identifies areas of underperformance and those of high performance as well. Operations excellence is made up of mining professionals with decades of mining, technical and processing experience. We're backed up by highly capable business analysts and data scientists. Our results are objective and genuine, supported by data, compared to peers and agreed with our clients. They're designed to provide a sustainable improvement pathway. 10 Times Performance Diagnostics is much more than smart data and like-for-like benchmarking. It also involves advanced data analytics and best practice scorecarding. Our business analysts and data scientists uncover trends and insights into the general ledger costs, equipment productivities, mining activities and processes. The best practice scorecard is a technique our team use to complete the performance picture. This helps to support conclusions drawn from the data analytics and to validate performance opportunities. This case study provides a small sample of the information collected and the results produced from a single performance diagnostic. After many years of successful operation, our client, one of the world's largest mining houses, was experiencing difficulty with deepening pits, high strip ratios, a declining reserve base and longer hauls. The AMC scope was to assess productivity and cost, mining method and planning practices. A year of productivity data was extracted from modular mining, the site fleet management system, and also from the general ledger at one level above transaction entries. AMC's engineers, business analysts and data scientists converted this information into performance diagnostics for every physical activity. These results were examined and the opportunities for improvement identified with our client. A summary of the truck fleet performance information is depicted on this slide. A utilisation opportunity has been identified because there's a high amount of non-productive time driven by no available operators and at times an excess number of trucks. Since purchasing additional fleet, further analysis of the truck utilisation trend line shows a drop-off in equipment hours, suggesting that adding the fleet has not increased output. Blending is a very important aspect of this mining operation, and 95% of ore is rehandled from field stockpiles to the crusher in order to meet the customer's grade requirements. In addition, the data shows that when single excavators are on a 12-kilometre long ore haul to the ROM pad, the other excavators don't actually have enough trucks. The opportunity then is to even up the hauls by using existing field stockpiles, keep excavators fully trucked and reduce their hang time, and address the lack of operators and improve operator travel logistics to and from their equipment. In closing, performance diagnostics has many applications, including to those interested in best practice and improvement, assessing their performance regularly, acquiring or selling assets, and completing feasibility studies. The work is carried out by specialised teams, selected with the necessary knowledge and experience to understand your operation. Thank you for your interest and for your attention.
Good day, and thank you all for coming to this AMC Masterclass. In the last decade, the global mining industry has begun to recognise the value of geometallurgy for improving tactical and strategic decision making. Many companies are now embedding geometallurgical modelling in their businesses. The geometallurgical model becomes a critical connection between all parts of the mining and processing operations and a key driver of project value. In this presentation, I will discuss how geometallurgical practice can be integrated into workflows, and I'll provide guidance on how to ensure that your geometallurgical modelling is a success. Let's begin with the question of when to start collecting data for geometallurgical purposes. A simple answer is as soon as you've discovered your mineral deposit, even before you've made your first mineral resource estimate. In mineral exploration and definition of mineral resources, drilling and the associated costs of mobilising and demobilising people and equipment to the project site are usually the biggest cost items. So it's important to make the most of the opportunity to collect data from every drill hole. Drilling additional holes later to collect data that could have been collected from the beginning is a waste of resources and money. Drill holes provide the opportunity to collect a variety of useful information to characterize the ore. The information that should be collected includes rock type and alteration from visual identification by geologists, mineral content from hyperspectral logging or X-ray diffraction analysis, grain size and texture, elemental content from assays, physical properties such as density, rock strength or hardness, geotechnical characteristics such as rock quality designation and fracture frequency. With good planning, the additional data can often be collected for little more than the cost of a normal exploration drill hole. The keys to success are the establishment of an integrated, efficient workflow at the field camp, the consistent use of correct, fully documented procedures, collection of measurable data using methods that provide repeatable results, structured digital data capture, and real-time validation of the data so that errors can be efficiently corrected or removed from the database. And it's prudent to complete a gap analysis at the earliest opportunity so that appropriate data types and methods can be selected to suit each mineral deposit. Metallurgical test work provides critical information about the processing response of the ore. Typically, the tests will provide measures of mass pull, metal recovery, concentrate grades, and comminution characteristics such as drop weight index and bond work index. Metallurgical test work is expensive, so it's particularly important to sample the right material and to execute the right test work program. Large composites are useful for establishing an appropriate process flow sheet and test work flow sheet. But for geometallurgical modelling, smaller samples from single continuous drill hole intervals are necessary to test the variability of the ore body. The variability samples must provide good geographic coverage and also good coverage in multivariate space. That is, they must include representatives of the full range of all the important characteristics of the ore. This is the main requirement that determines how many variability samples will ultimately be required for a successful geometallurgical model. Having selected the variability samples, it's important that a consistent test work flow sheet is applied so that the results of the tests are comparable. Varying the test work flow sheet or the test work parameters may weaken or completely invalidate the geometallurgical model. And of course, the test work flow sheet must be aligned with the full-scale process plant flow sheet. When the variability test work has been completed, the geological data and the metallurgical data can be joined, and data science methods can be applied to derive predictions of ore processing responses from the geological data. Comminution parameters such as drop weight index and bond work index can be used to estimate power consumption or throughput rate, which are critical economic considerations. This can be done using various mathematical models or by using software that simulates the operation of the proposed process plant. For example, AMC builds a virtual model of the process plant flow sheet, including equipment specifications, using integrated extraction simulator software. Then, by using the geometallurgical model as input, the throughput can be estimated for each block in the model. A key point to note is that extreme values or outliers in the data should not be excluded from the analysis unless there is good evidence that they are real errors. On the contrary, extreme values are useful in data analysis because they help to control the predictive models over the full range of the data. Predictive models that are generated using only data points that are close to the average are unlikely to perform well for ore that has less common characteristics. So, for example, including samples with unusually high or low grades in the regression modeling often produces more robust models. Modern data science provides many powerful tools for analyzing multivariate data. For a successful geometallurgical model, the skills and experience of data scientists must be joined with the skills of the geologist and the metallurgist. Complex multivariate data is difficult for human beings to visualize and interpret, but there is a variety of dimension reduction techniques that are extremely useful in this regard. AMC has found that the UMAP algorithm is very useful for comparing the multivariate characteristics of metallurgical samples with the characteristics of the whole drill hole data set to assess whether the metallurgical samples provide good coverage in a multivariate sense. Regression techniques are used to provide estimates of ore processing responses on a sample by sample or block by block basis. There are many different algorithms available. Machine learning algorithms, such as the cubist method, can commonly be trained to perform better than traditional linear regression techniques. Sometimes, estimation of processing responses on a sample by sample or block by block basis is not possible. An alternative may be to classify the samples or blocks into groups with similar characteristics. Again, data science provides a variety of tools for this purpose. Developing predictive relationships is important, but to get full value from them, they must be applied to the block model so that they can be used in planning the development or operation of the mine. There are several important issues to consider when applying predictive models to the resource block model. The resource block model must contain estimates of all the variables required for input to the regression models. If not, the missing variables must be added to the resource block model or a simpler, less accurate regression model may be required. The multivariate relationships observed in the drill hole data must be correctly preserved in the resource block model. For example, if a positive correlation between two elements is observed in the samples, this must also be preserved in the block model. And we must consider whether the variables are additive. That is it correct to calculate a linear average of the variable? Some variables, such as percentage recovery and the comminution parameter called A times B, cannot be averaged, and alternative methods must be applied. Careful consideration of these issues is critical to the success of the geometallurgical model. The major benefit of a geometallurgical block model is that it provides the foundation for a change from grade-based planning and operations to value-based planning and operations. The value of a block of ore is a function of the grade, recovery, energy costs, reagent costs, and product quality. The value of a block of ore and its position in the mine schedule must consider any constraints or bottlenecks in the processing plant. The geometallurgical model carries the estimates that allow these revenue and cost parameters to be estimated for every block in the model. Unfortunately, geometallurgy is currently unable to solve the problem of estimating future product prices. So the geometallurgical block model becomes the enabler of value-based strategy optimization, long-term planning, and short-term planning. The move to value-based planning requires a change in planning philosophy, but the planning procedures are not changed. Experience shows that value-based planning can add hundreds of millions of dollars to project value. When there is a change from grade-based planning to value-based planning, grade control must be transformed to ore control, which considers all the ore characteristics that are important in the geometallurgical model. Ore blocks are defined according to their value and a holistic assessment of how they should be managed to maximize returns. Good data, good science, and clever data analysis can produce significant improvements in understanding and prediction of ore behavior. But success cannot be achieved unless the human factors are also properly managed. People tend to have biases and preconceived ideas. This is a natural part of being human, but it can block the successful development of a geometallurgical model. Steps to avoid biases include geologists, metallurgists, and mining engineers engaging with the data scientists to build mutual understanding, testing ideas and seeking multiple perspectives, and acknowledging that you don't know what you don't know. The algorithms used by data science to predict ore behavior can be complex and not easily interpreted, but this should not be a barrier to acceptance of the geometallurgical model. We don't all need to understand the algorithms used to control an autonomous truck. Similarly, we don't need a geometallurgical model that can be exactly replicated in a spreadsheet. We need to build smart trust by testing, evaluating, and improving the models. A good geometallurgical model is more likely to be limited by the small number of data points than by the algorithms on which it is built. And finally, but most importantly, it's critical that all members of the project team, the geologists, metallurgists, mining engineers, and senior management all support the use of the geometallurgical model as the primary tool for short-term and long-term planning. They must all be on board the same train. Any divergence will derail the benefits of the model, but a team fully committed to the geometallurgical model and value-based planning will provide the fastest route to success. Thank you very much.
Thank you all for joining me here today to listen to AMC's presentation on strategy optimization using the Hill of Value. My name is Jason Tolley, and I am the advisory lead for strategy optimization. My career has mainly been focused around underground mining across multiple commodities and numerous mining methods. At AMC, I'm responsible for the strategy optimization team, The core focus on de-risking projects, unlocking the potential and maximising value for our clients to achieve their preferred strategic position. So what is strategy optimization? It's about finding the right mix of organisational, commercial and operational settings which best achieves a mining company's corporate goals by balancing return, which could be NPV or IRR, longevity or mine life, and risk, which could be technical, environmental or financial, all within a mining asset's physical, commercial, statutory and financial constraints. In this presentation, we'll be taking you through AMC's Hill of Value process, the industry's most robust and comprehensive evaluation available, flexing multiple inputs and scenario combinations to uncover all the available options for company executives to make more informed decisions to achieve their preferred strategic position. So where is the mining industry's focus? In this day and age, there is a lot of emphasis on improvements in productivity, efficiency, reducing unit costs, reducing the CO2 footprint, and various other parameters. Improving all of these is important, but we often miss the fundamental issue. Do we have the right strategy? It's all well and good to be able to run the 100 meters in 9 seconds, but it doesn't help if you're running in the wrong direction. Once we have identified the right strategy, we need to execute it efficiently. So what are the key issues with the mining industry's interpretation of optimization? Unfortunately, optimization is an often misused buzzword where improvements are often labelled as optimizations which only focus on a few aspects of the business. The industry needs to distinguish between what is strategy selection and what is strategy optimization. A typical strategy selection is where several parts of the business are assessed to create a limited number of fixed strategies with preset inputs for evaluation. Engineering resources generate detailed plans and schedules where all options and decisions are essentially locked in before any economic evaluation has been performed. Sensitivity analyses can flex these scenario values, but what is the impact of scenario uncertainties on the value of a specific plan? This selected strategy could be both technically feasible and economically viable, but more than likely not optimal. So in the typical strategy selection model, first the engineers will generate the production and development schedules based on production targets with some form of desired commodity outputs that's controlled by the mine design criteria, the scheduling constraints, and other key inputs such as geological setting, geotechnical parameters, or any unique mine conditions. Next, the project CapEx, capital cost, is estimated by assessing the debottlenecking options, which could be a new materials handling system or a process plant upgrade. And we assess where and when in the production plan this project capital cost will need to be spent. This includes any closure costs towards the end of the mine life. Once the capital costs have been estimated, typical additional parameters such as metallurgical recoveries, revenue data including commodity prices and any offsite costs, sustaining capital costs and operating costs are all added to each option. All of this is then fed into a simple model which produces results in the form of a handful of options where we can compare against a set base case. And only then can we make decisions that hopefully achieves the corporate goals. The issue with the strategy selection process is if we cannot achieve the corporate goals, we need to reassess the full cycle again from the production and development schedules. For the strategy optimization process, all parts of the business are assessed within the evaluation model. Engineering resources generate the relationships and all the decisions are flexible, not constrained by what any form of software can do. Sensitivity analyses flex both the decisions and scenarios, which leads us to 3 fundamental questions. How do decisions impact the value of an operation given certain scenario assumptions? What's the impact of scenario uncertainties on these decisions? And what's the plan that best delivers the corporate goals given these uncertainties? AMC's strategy optimization model takes into account all the same inputs, including the corporate goals, which are then assessed in a robust model as key to the Hill of Value process. Essentially, if you can describe it, we can model it. From here, you can make a far more informed decision to optimize your strategy. If the corporate goals change, we can model this and directly influence any key decisions. To begin with the hill of value process, we start with all the given and changeable data inputs. Next, we assess the relationship between these inputs and we build a robust model that can optimize any value measured. Then we enrich the model through the lens of probability and sensitivity by overlaying common scenarios that might happen over the course of the mine's life cycle. Through our robust and comprehensive assessment of multiple combinations, the hill of value process identifies all the strategic opportunities available to help you understand the trade-offs. This enables you to make a far more informed decision and select a preferred strategic position with confidence. So how do we climb the hill of value? In this case study, we have an underground operation with increasing cutoff on one axis, increasing production rate on the other axis, and increasing value on the third axis, where again value could be NPV, IRR, mine life, or any other form of value measure. All of these creating our hill. What's key here is the shape of the hill and how it responds to a multitude of changes. We typically start with the current state of the operation, which in this case was a long way from optimal. The improvement proposal due to low commodity prices was to increase the production rate. In this instance, we actually passed the optimal rate ridge, and after an influx of project capital, we have landed in a place that didn't improve the overall value. The better solution in this case was to increase both cut-off grade and the production rate to de-risk the project and maximize value. This is how we climb the hill and how we can confidently select your preferred strategic decision. As part of the hill of value process, similar hills should be created based on various factors of interest, other mining methods considered, or informed trade-offs between options for the best overall strategy. Thank you all for your time.
Thank you very much, Mark, for interesting presentations of your colleagues. Could you please clarify your database? How much it does include specificity of Russian mining data to be able to compare Russian mines with the rest of the world? Thank you.
Several Russian operations within the database and quite a few more from Canada, where very similar conditions are existing, particularly with the underground operations. We've got several studies underway over the last 5 years that have provided additional points to those operations for comparison with Russian periods. Particularly with the underground, there's a great opportunity, I think, for comparison with other foreign operations to identify improvements that can be made with the existing Russian underground. Thank you.
And one more question in this regard, if I may. How about alluvial mines or wet mines, wet mining data in particular?
Alluvial mines, I'm not sure if we've got anyone online. I'm not exactly sure how many data points we've got with, say, sand mining or wet mining. There are significant alluvials in terms, or near surface deposits in terms of lateritic nickel, bauxite, those types of operations. But as far as dredging, I'm not sure how many we've got in that in the database. Do we have the guys online in Australia? They are there. So we have Ian Lipton, Jason Tolley, David Vink. If there are any other questions, we can ask them directly. The other option is that tomorrow we're looking to do a live cross from our booth here in at MINEX, where the guys will be available also to answer questions online. The other thing is, are there any questions from the online audience now? I'm not exactly sure how this works, so apologies for the uncertainty. All right, the whole idea of the strategy optimization is to make sure that we're considering multiple options in any project. When you first conceive of a project after you've had discovery and started drilling, there is a tendency to assume that there is a path that you should follow. That's not the case. We need to be data informed, and as we're collecting more and more data in the new and modern age, we have the ability to direct the way that a project develops over time. Geometallurgy is very important. Operations improvement is important because it allows you to define alternatives and alternative ways of going about a mining project. And optimising for the objectives of your company is really an important step in defining the project for the future. And that's what we're about, is to pull all of these things together, including the very hot topics now of environment and social requirements for various companies. All right, so one last chance. If there's no further questions, I'll wrap up here. So I just wanted to, in closing, thank the MINEX organisers again. We've got the first masterclass for today. There'll be some further classes happening throughout today. And remind everyone that they can find us after this class now, and we'll be around for a few hours this morning. And our specialists will be at the booth tomorrow and on Thursday. And we should have the ability to talk to other specialists in other AMC offices by arrangement. We've got several geologists here. Narina, Senior Mining Engineer, is available. Katrina and Olga, Geology, here at the booth. So please approach any of them, ask questions. And also announcing that we're transferring a metallurgist to our Moscow office in November. Rob Cheshire, he's 40 years of experience, particularly in the copper operations. Thank you very much for your time, and I look forward to discussing further issues with you throughout the conference. Thank you very much.